Hey students, it's Mr. Lucido. Just wanted to create this quick video walking through how to go about solving these two pedigree examples we saw last week. So the way that I like to always start these is actually by writing out the four different options for the mode of inheritance. In other words, how a trait is inherited. And so based on the question, right, those options are autosomal dominant or autosomal recessive. And then we have the other two options, which are X-linked dominant or X-linked recessive. Okay, so now that we have those options written down, what I'm going to do is go through why either the option does work or doesn't work according to what we see in the pedigree. And actually there is one hint on this pedigree that you can actually use to eliminate the two of the options here. And that is, if you take a look, it looks like this pedigree has marked carriers, right? In other words, individuals who carry an allele for the trait but don't actually express the trait as their phenotype. That is not possible if the trait is dominant, because we know that as long as you have one dominant allele, you'll express the dominant phenotype. So just by the fact that there is three carriers in this pedigree, we can actually eliminate autosomal dominant and X-linked dominant, right? Because again, that's not possible if there are carriers present. So then that leaves autosomal recessive or X-linked recessive. Okay, so to determine if it's autosomal recessive or X-linked recessive, what I like to do is just to walk through some parts of the pedigree, assuming that it's either one of these. So let's start with autosomal recessive. So if the trait is autosomal recessive, that means that the genotype for these individuals in generation 1 must be, using the letter R, for example, heterozygous, which is the carrier genotype. And then this individual, number 1, is not marked as a carrier, so we can assume that he is homozygous dominant. Okay, so looking at their offspring, is this possible? Well, so it turns out this first son has this trait. And remember, since this is an autosomal recessive assumption that we're working through, that must mean his genotype is lowercase r. That does not work considering the parent's genotype. So autosomal recessive is eliminated as a possible option because of what we see in individual 1 in generation 2. Okay, then that leaves X-linked recessive as our only option. Let's just make sure that that actually works. And so if we take, for example, this first set of parents, let's write their sex chromosomes here. So we got XY for the father and XX. Again, if this is X-linked recessive and mother is a carrier, that means she would have that genotype, and the father doesn't have the trait, and so that means he will have the dominant version of the trait. Then, looking at this son, is that now possible? Well, so we know that the son is going to inherit his Y chromosome from dad and must have inherited the recessive allele from mom. So that checks out, that's possible. As we go through these other examples here, son number 2 received his Y chromosome from his father and must have received the dominant allele from the mother. So that checks out. Okay, and then looking at the other 2 daughters here, right, that must mean this daughter who's a carrier received her dominant allele from the father's X chromosome and then a recessive allele from the mother, allowing her to be a carrier. And then lastly, we have this daughter right here who was guaranteed to receive the dominant allele from the father and must have received another dominant allele from the mother because she's not indicated as a carrier. So, based on the information that's provided in the pedigree, this most likely is an X-linked recessive trait, and we've eliminated the other possible options as well. Okay, so let's do one more example here. This was example 2. So again, I prefer to start just by writing out those 4 options. So again, autosomal dominant, autosomal recessive, and X-linked dominant and X-linked recessive. Okay, and then just like we did in the previous example, we're just going to go one by one to eliminate some of the options and hopefully narrow down to just one option. Okay, so right off the bat, we notice that there aren't any carriers marked in this pedigree, which doesn't necessarily mean that they're not there, it just means that they're not indicated. Okay, so then that doesn't eliminate any options. So maybe let's start with looking at autosomal recessive. I'm going to look at this as an option. So autosomal recessive, if that was the case, that would mean that these 2 parents, just using the letters R again, must be homozygous recessive, right? Because if this trait that's being tracked is autosomal recessive, it's only going to show up if we have 2 copies of the recessive allele. Now, with that being the case, that would mean that all of these children from this set of parents must have the same genotype because there's only one possible genotype. But it turns out that these 2 daughters don't have the trait, which is not possible if this is an autosomal recessive trait. So that option is eliminated based on what we see of the daughters in generation 2 not having the trait. Okay, so autosomal recessive doesn't work. Let's try X-linked recessive. So if that's the case, again, that would mean this set of parents, their genotypes must be this. All right, if this is an X-linked recessive trait, those are the only possible genotypes for mom and dad. And again, when we consider these 2 daughters, right, that don't have the trait, that's actually not possible if, again, the only thing that they can receive are 2 X chromosomes, each with a recessive allele. So that is not possible either. Okay, so that leaves X-linked dominant and autosomal dominant. So for X-linked dominant, let's run through this with the genotypes again. That means that the father must have this genotype, and the mother, right, the 2 options could be that she is homozygous dominant or heterozygous, like this. Both would give the phenotype. However, looking at the offspring again, if we focus in on these 2 daughters, right, who have, in this case, the recessive form of the trait, because remember that we're assuming the trait being tracked, shaded in, is X-linked dominant, that must mean they had to have received a recessive allele. They're not going to get that from the dad, though, because he's only got 1 copy, and it's the dominant allele in this case. So that must mean it came from the mother, so it eliminates this as a possible option. But even still, right, the daughters are always going to receive an X chromosome with a dominant allele from dad, regardless of what they receive from mom. So it actually turns out that this is not possible for the trait to be X-linked dominant. Otherwise, these daughters should be shaded in since they're always receiving a dominant allele from dad. Okay, so then that leaves autosomal dominant. We've narrowed it down. Let's make sure that this checks out, though. Okay, so for it to be autosomal dominant, that means that these parents both have to be heterozygous. Okay, and remember that this one dominant allele allows them to have the phenotype since the trait, again, is autosomal dominant. This also allows for what we see with these two daughters, right, who each received one recessive allele from each parent. That works. These two children here, again, this daughter could either be homozygous dominant or heterozygous, but we know that this son is got to be heterozygous since he has a daughter that must be homozygous recessive. So this all checks out. The last part of this pedigree also checks out, right? That means that this son who married the daughter of the parents in generation 1 must also be homozygous recessive, and if we look at their children, all of them don't have the trait, which also works considering this cross. So this is most likely an autosomal dominant trait. So again, I hope that was helpful. I, again, like to go one by one and test it out, kind of like a puzzle, but please reach out if you have any questions.